Okay, I was going to start from past papers, but I changed my mind. And the reason is that if you solve past papers, what you're doing actually is you're jumping between topics, right? From one topic to the next to the next. So you don't get enough practice to feel confident about one topic. So I would suggest that we start with topic wise problems so that once we finish problems on one topic, you feel more confident about that topic. When you see that topic on paper on an exam, you will look at it and think that, okay, I've solved many problems from this topic and I can do this one. So I think that's a better approach. Now, the first topic is from, I think this is second chapter, equations of motion and motion graph questions. Okay, for motion graph questions, let's write some of the basic things. So for example, for velocity versus time graph, first of all, slope will give us, for velocity time graph, slope gives us acceleration, right? And what about area under the graph? Area under the graph for velocity time graph will give us the distance traveled. But if this were a distance time graph, then the slope will give us velocity instead of acceleration. So the definition of slope is change in y divided by change in x. So if you write the slope, well, let's represent slope by m. You'll do change in y over change in x. But since on the y-axis we have velocity, on the x-axis we have time, you will get change in velocity over change in time. So which is basically acceleration. So you can find for any given axis, for example, velocity time, distance time, you can find what the slope represent and what the area represent. Okay, now we can answer these questions based on these two concepts. Describe carefully the motion represented by line AB and BC. So as you can see, going from A to B, you see a line, a straight line that has a constant slope. So we can see that it is a constant acceleration, right? By the way, if a line is going like this, it doesn't mean that the slope is increasing. It means that the slope is constant, right? It is the angle is not changing. If the line were going like this, then we will say that the slope is changing and the acceleration is changing. So most of the students, they look at the graph, at this graph, and they say, okay, slope is going up, so acceleration is also going up. It's not like this. This is just a positive slope. It is a positive slope and it is a constant slope. So we'll have positive constant acceleration. And for the next one, which is from B to C, now what is happening exactly? Now you should always remember that this is also it will be used throughout the graphs. It doesn't matter which graphs you're looking at, if they're graphs in calculus or physics, it doesn't matter. But if you see a straight line like this going up, you should not think this line as part of the graph. Okay, this just represents a jump from this value to this value. So for at this point, at point B, velocity will have some value. Let's say it's this, and suddenly it jumped or dropped from this value to 0. So the velocity went from some positive value to directly to 0. So it is a jump. It is a sudden jump, and these straight lines, vertical lines on the graph, they represent these jumps. Okay, there is no information on this line except that it is jump. Now what is this jump representing? It represents a certain collision, because this is the diagram for an electron. So maybe electron was going at some velocity and suddenly it collide with an atom or lattice point and the velocity dropped to 0. So it represents a collision or a sudden drop in velocity, right? Also, if you look at it in terms of the slope, so this line is going down and it's kind of like negative. So it represents infinite deceleration, but there is no such thing as infinite deceleration. So you can just ignore this line, this vertical line, and say that the velocity dropped from some positive value directly to zero, and which in case of the electron represents a collision. The second question is, the graph is a much simplified model of how an electron moves along a wire carrying current. Explain what causes the motion represented by AB and BC. So for, of course, AB electron is increasing, it's accelerating. So this must be because of the applied voltage. So you can say that the motion from A to B, in which the electron acceleration is because of the applied potential difference, and from B to C is because of collision. The next question is, explain the term drift velocity and indicate its value on the graph. Now, drift velocity, we will talk about it in electricity and circuits. So I will explain it in detail in that section. We'll skip it right now. With reference to the behavior of electrons, why the wire gets warm again, I will discuss it in electricity and circuits. The short answer is that because of the collisions, and because of the collisions, the electrons lose some of the energy, and the energy which the electrons lose, it gets converted into heat energy, and the wire gets warm. Next, we have the diagram shows a velocity time graph for a ball bouncing vertically on a hard surface. The ball was dropped at time t equals 0 seconds. At what time does the graph show the ball in contact with the ground for the third time? Now let's understand the graph first. Like I said in the previous question, these vertical lines, these dotted lines, they are not part of the graph. They just represent a sudden change in velocity. When the ball hit the ground, the velocity goes from -5 to +5. I'll explain. I'm sorry, not +5. +5 is this point. It's somewhat lower than +5. Okay, so what happens is that when the ball is falling down from, let's say, this height, the velocity is negative because it's going down. And you see that by this first line, the velocity is in the negative direction, and you see a constant slope because the acceleration is constant, and the acceleration is just the acceleration due to gravity. At this point, the ball bounces from the ground, from the hard surface, and suddenly it starts going upwards, right? Now, as soon as it starts going upward, its velocity changes from negative value to a positive value, and it will have the highest velocity as soon as it bounces back. And as it goes up, the velocity will decrease, right? So that's why you see that the velocity starts from some positive value. It jumps from negative value to positive value, and then it starts decreasing again as the ball is going up, right? Now, the question is, the first question is very easy. The third time the ball is contact with the ground, this is the first time, this is the second, this is the third time. The second question is, the downward sloping lines on the graph are straight and parallel with each other. Why? The reason is very simple. The slope represents the acceleration, and because acceleration is constant, so that's why all of the lines must have the same slope. It doesn't matter whether the ball is going down or going up, they will have the same negative acceleration. Okay, the next question is, show that the height from which the ball was dropped is about 1.2 meters. Now, this question you can solve using two different methods. You can pause the video, think by yourself if you can figure it out, what two methods you want to use or you can use. I'll give you a hint. One of the method that you can use is an equation, and the second method, you can find the distance from the graph. The equation that you have to use will be one of the three equations of motion or kinematic equations. So the two equations that has distance in it, the first one is S equals VIT plus 1/2 AT squared. Some textbooks and some teachers write it as UT plus 1/2 AT squared, where U represents the initial velocity. I'm used to using this notation, VI for initial velocity, VF for the final velocity. So I'll use this one. You can use whichever you find easy. The second equation that has distance in it is 2AS equals VF squared minus VI squared. So we can use both of these, but if you use the second one, the first one, you see we'll have to read the time from the graph. We'll have to zoom in, count the number of squares and everything. So we can avoid that by using the third equation. In this, well, it's the third equation, but right here it's the second equation. You can set vi to 0 because the initial velocity of the ball was 0. The final velocity is -5, and you can find the distance. So the height will be vf squared divided by 2a, right? And it will be 5 squared, which is 25, divided by 2 times 9.8. And if you solve it, you will see that it's about 1.2 meters, which we need to prove. Okay, which they asked us to prove. So the next question is a bit tricky, but I'll try to explain it in some detail. Let me clear this area. So the first thing that you need to understand is how to represent acceleration on displacement versus time graph. On velocity time graph, the acceleration is represented by a straight line going up or downwards if something is going down, right? But on distance or displacement versus time graph, the acceleration is represented not by a straight line, but instead by a curved line like this, right? Because I don't want to go into details, but acceleration is the second derivative of displacement. So you can think of it like this. Because it's the second derivative, that's why you get a exponential graph for displacement versus time graph if you want to represent acceleration. So this displacement versus time graph, this shows acceleration. So if you get everything wrong in this graph for this question, make sure that your graph does not include any straight lines at least, okay? It should be curved. So this is the first thing that you need to understand. The second point that you need to understand is that what is happening to the velocity as the ball is falling down. The velocity is increasing, right? And it is increasing in the negative direction. So for example, if I draw the graph like this, for example, right? Let me exaggerate it a little bit like this. Now you see this slope at this point, it is more steep. And if I calculate the slope at this point, the line is less steep, right? And what does slope represent on the displacement versus time graph? Slope gives us velocity, right? So if the slope is more steep here and less steep at this point, that means the velocity will be greater at this point and lower at this point, which is not true, right? Because as the ball starts falling, the more it falls down, the more velocity it gains. So this is the second point you need to understand, that when something is falling down, the velocity time, the displacement time graph is not a curved line going like a slide. It is actually something like this. So for the first 0.5 seconds, it's going down. I think now this makes more sense, and this is in line with our understanding of the slope, right? So here the velocity is almost 0 because the slope is 0, and as it goes down, the velocity keeps increasing as the slope increases. So now it makes sense with our understanding how things fall. And when it hits the ground, now it will start going up. Now when it starts going up, again, the velocity will be higher at first, and as it goes up, the velocity will decrease, right? So how will the slope change? Should it be like this? Here you can see the velocity is smaller, and as we are going up, the velocity is increasing. In other words, the slope is increasing. So this is not correct, right? The ball should be decreasing in speed as it goes up. So again, it should be like this. here you can see that here we have some maximum slope, and as the ball goes up, the slope is decreasing. The slope is becoming more and more flat, and that represents that the velocity is decreasing. And the fact that I have made it not to the same level from which it was dropped, the displacement, has to do with the fact that if you read this graph, you see when it bounced back, it didn't start from the same velocity of positive 5, right? So it started from a smaller velocity. It means that it will not go up to the same height. It will not go up to the same height of 0 or this ground level. It will be somewhere here. And they asked us to draw the graph for the first second. So this is the first second. And that's it. I hope you understood the thing about the slope of the line. Okay. One other thing that I have seen my students, they make this mistake. They think that, okay, if the graph looks like this, it means that the ball is falling like this and it bounced back like this. This is not true. Okay. This is just the displacement time graph. Maybe the ball is just falling straight down and then bouncing straight back up, right? So even for this diagram, you will see this. Even for this case, you will see the same diagram. But I have a question for you. If you have already studied projectile motion, can you tell me if I draw the displacement versus time graph, or the displacement in the y direction versus time graph for this motion, how the graph will look like? Or will it change, or will it look exactly the same? Okay, so you can tell me your answer in the comments. If the ball is, instead of going up and down in one dimension, if it is going like this, how will the graph for its height as a function of time will look like? Draw the graph for height as a function of time for this case. This is your homework. Okay, what is the displacement of the ball when it finally comes to rest? This is the last question. And remember, the displacement is the total distance between the initial and final point, right? So if you drop the ball from 0 height and it dropped to the ground, of course, when the ball finally comes to rest, it must be on the ground, right? If it is on the ground, the total displacement is the height from which it was dropped, right? The height was 1.2 meters. So the displacement will be, again, it will be the same as the height from which it was dropped, 1.2 meters. But since displacement is a vector quantity, so you need to be careful. You need to write this. You need to put the correct sign with this number. If this is your 0 level, so this will be negative 1.2. This is negative displacement. And that's it. Okay, next question is, a ball is dropped from a high window onto a concrete floor. The velocity time graph for part of its motion is shown. Calculate the gradient from the origin to A. Now at this point, you must be thinking that, okay, I can solve this by myself. You see, that is the benefit of doing topic-wise questions, because after you have solved 1 or 2 questions, you feel more confident about solving the next one. So I would ask you to stop this video right now and try this question by yourself. I think you should be able to answer most of the questions correct. I'll explain it here. The gradient is just the slope. So gradient and slope mean the same thing. You just calculate change in y over change in x. So change in y is the second height, the final value of velocity minus the initial value of velocity. So 30 minus 0 is 30, and divided by the change in x, which is the final value on x-axis, which is 3, and minus the initial value, which is 0. So 3 minus 0 is 3. And be very careful, you have to use the right units. The units should be meter per second for velocity divided by second for time. And the units that you should get will be meter per second squared, which is the unit of acceleration, right? Comment on the significance of your answer. So of course, the gradient of velocity time graph, like I said, it gives you the acceleration. So you can say that the gradient gives the acceleration due to gravity, which in this case, it's about 10 meter per second square. The actual value is 9.8, so it's not exactly 9.8, but it is 10 meters per second. The next question is, what happened to the ball at point A? So at point A, like I said, the vertical lines in this graph do not mean anything. It does not mean that the ball is going down or something. It just represents a sudden change in the velocity. So you can say that the velocity changed at point A, or the ball bounced back from the concrete floor, right? Because that's the point when the ball will change its velocity. And the last question is, calculate the height of the window above the ground. Now, in the previous question, we already solved a similar question, but for the previous question, we used the equation to solve for height. But for this question, I will use the second method, which is by calculating area under the graph. Remember, in the start of this video, I said that if you find area under the curve or area under the graph, or for velocity versus time graph, it will give you area, it will give you distance traveled, right? So to find the height, we can simply calculate this area under this graph. And if you look at this shape, it is just a triangle. And we know that the area of a triangle is given by 1/2 base times height. Base is 3, height is 30, and you divide it by 2. So 3 times 30 divided by 2, whatever is the answer, will be the height of the window above the ground. Next up, we have the graph shows the variation of velocity with time for a body moving in a straight line. Calculate the total distance traveled. Now, if you have watched the whole video from start, this must be very easy for you. So you see you are kind of gaining momentum, right? You're solving more and more questions, and the more questions you solve, the next one is more easier for you. So total distance, you can again use the equation, or you can use the graph. We will use graph here, but this graph, to find the area under the graph, you can see that we'll have to divide it into 2 different shapes. So from here to from 0 to 10, it is a square, and from 10 to 20, in the final 10 seconds, it is a triangle. So you have to calculate the area of these 2 shapes and then add the area together to get the distance traveled, because area under the graph of velocity versus time graph gives you distance. So area of a square is very easy, just length times height, and the area of the triangle is also 1/2 base times height. So I'll just write the formula. You can calculate it by yourself. The base is 10 for the square, times the height of the square is 20, and you add this to 1/2 base of the triangle, which is 10, times the height of the triangle, which is again it's 20. So this will give you the total distance traveled. Remember, you should always write correct units for distance. The units should be in meters. So the second question is the average speed over 20 seconds. Now, the average speed, the formula for average speed, V average, is very simple. It's the total distance divided by total time. So if you have solved the first question correctly, you have the total distance. You just divide it by total time, which is 20 seconds, and this should give you the average speed over the 20 seconds. Next question is, a lorry is traveling at 25 meters per second down a mountain road when the driver discovers that the brakes have failed. She notices that an escape lane covered with sand is ahead and stops her lorry by steering it onto the sand. The lorry is brought to a halt in 40 meters. Calculate the average deceleration of the lorry. Okay, again, you'll have to use kinematic equations. So I'll write the kinematic equations. Vf equals Vi plus At, and the second one, S equals Vit plus 1/2 At squared. The third one, 2as equals Vf squared minus Vi squared. Now I'll ask you to stop the video and think, which of these three equations should we use? Now, the first equation has time in it. We don't know anything about time. It's not given in the statement, so we cannot use any equation that has time in it. So we cannot use the first, we cannot use the second one. We'll have to use the third one. Let's see what quantities are we given in the third equation. So we know what the initial velocity is. It's 25 meters per second. The final velocity, it's not given explicitly, but it's kind of hidden. You need to understand that when the lorry stops, the final velocity will be 0, right? And the distance traveled is 40 meters. And we have to solve for acceleration. Acceleration will be actually negative, which will mean that the acceleration is actually deceleration. So let's just rearrange this equation for acceleration. It will be a equals negative vi squared divided by 2 times a. Divided by 2 times s, which is 40. So you just calculate this, 25 squared divided by 2 times 40, and you should get a negative answer for acceleration, which means that the lorries, that the truck is applying brakes, not applying brakes, that the truck is decreasing its speed and it is decelerating. The next question is, suggest how the depth of the sand affects the stopping distance. Justify your answer. Now, of course, the truck stopped in the first place because of the friction between the sand and the tires, because the brakes are not working. So if we have more sand, there will be more friction between the sand and the tires, and the stopping distance will decrease. So you can just write that the stopping distance will decrease because the resistance between the sand and the tires will increase. Okay, question 6 says, two cars A and B are traveling along the outside lane of a motorway at a speed of 30 meters per second. They are distance d apart. The driver of car A sees a slower vehicle move out in front of him and brakes hard until his speed has fallen to 22 meters per second. The driver of car B sees car A brake, and after a reaction time of 0.9 seconds, brakes with the same constant deceleration as A. The diagram below shows velocity time graph for car A, represented by solid line, and car B, represented by broken line. The first question is, find the deceleration of the cars whilst they are braking. So we have solved many questions on this. We know that for velocity time graph, slope of the velocity time graph will give us the acceleration. So we just have to find the slope. So let's find slope for this line. Since both are parallel, so they'll have the same slope. So to find slope, we need change in y, which is the difference between these values. And we also need change in x. Now be very careful. Since we're finding the slope for this line, we need the change in x to be the distance from here to here. So this is change in x, not this distance, okay? This is something else. This is not even the distance for the change in x for B, line B. Even for B, it will be something extra here, okay? So if you count the squares and see how they have chosen the scale, you will see that each this small square represents 0.5, right? And if you count the number of squares, you will see that the difference from here to here in y is about 8 meters per second. Also, you should always use the correct units, okay? Since the quantity on the y-axis is velocity, and velocity has units of meters per second, so change in y will actually be the change in velocity. It should also be written with the correct units, meters per second. And now you divide by change in x, and if you count the number of squares here on the x-axis, each small square is actually 0.1, okay? And if you count the number of squares, you will see that they are 1.3. So 1.3, and the unit is seconds. So you see, we have meter per second in the numerator and second in the denominator. The final units will be meter per second square, and you will get some value here for acceleration, which will be 8 divided by 1.3. Next question is, what does the area under a velocity time graph represents? Now, they're not asking about the area which is shown here, which is the shaded area. They are just asking you, what does the area under a velocity time graph represent? So any velocity time graph, we know it's very simple. The area under velocity time graph gives you distance, right? Next question is determine the shaded area. Now we have to find this area. To find the area of this shape, you just need to multiply base with the height, right? So this is base. Now, if you measure this, you will see that it's 0.9 seconds, and the height is the same, which we calculated for the first question, 8 meters per second. So area will be 8 meters per second times 0.9 seconds. You will see that seconds will get cancelled with seconds, and you will get the correct units for distance, which are meters. So 8 times 0.9, it would be about 7 point something, and you will get the units of meters in the end. Next question is state the minimum value of the initial separation d if the cars are not to collide. Explain how you arrived at your answer. Now, this is a tricky question and also an important question to understand velocity time graphs. Now, we know that this shaded area, it is the shaded area for velocity time graph, and it should represent some distance, but what distance is it representing exactly? Okay, this is, by the way, if I will ask you to pause the video and think about what distance is this shaded area representing. Is it the distance that car A travels while applying brakes, or the car B travels while applying brakes, or is it something else? Now, to explain this, you can think about it like this. So if I calculate this area, this is the area under the velocity time graph of A while it is applying brakes. This is the distance that car A will travel while it is decelerating after applying brakes at this point. What about the distance that car B will travel while applying brakes? It will be actually this area under the graph of B, right? So this area will be the distance that car B will travel while applying brakes. So since initial speed for both of the cars was the same, both have the same deceleration, you can see that this area and this area is also the same, right? The distance that both cars will travel while they are applying brakes is the same. So the cars will not get close or away from each other while they are applying brakes. The cars will get close to each other because of this extra distance that B has traveled before applying brakes, right? Extra the time that the time that the second car, which is car B, the time that car B took to apply brakes, and in that time it covered some extra distance, right? So if you calculate this shaded area, this area is actually representing the extra distance that car B has traveled before applying brakes. Now, if this distance is, if the initial separation, which is d, if this separation is greater than this distance, then they will not collide. And if this is smaller than this distance, then they will crash. Both cars will crash. Car B will crash into car A, actually. So in this question, they are just asking, state the minimum distance, and minimum initial distance d if the cars are not to collide. So the minimum initial distance should at least be exactly equal to this area, this gray area that we calculated here in this question. So you can say that d should be at least equal to A if the cars are not to collide. The next question is, suppose that instead of only slowing down to 22 meters per second, the cars had to stop, add lines to the grid above to show the velocity time graphs. In this case, assume that the cars come to rest with the same constant deceleration as before. So it's very simple. Now they have only slowed down to about this velocity, which is about 22. Now, if you want them to stop completely, so they must keep on decelerating with the same constant deceleration, means you don't have to change the slope of the line. So it will be the same line like this. The next question is, explain why a collision is more likely. Now, again, the collision is more likely because B, for example, look at this point here. At this point in time, which is about 4.8 seconds, car A has stopped, right? But at the same time, if you look at car B, it is still moving, right, with this velocity. So when car A started applying brakes at this point, the car B was moving with some velocity. So because of this velocity, some of the distance between B and A will decrease. And at the end, car A will stop before car B. As you can see, car B will stop at 6 seconds. So at the end, car B will again cover some extra distance than car A, right? So now the collision is more likely. Okay. Okay, one last question from this topic. An athlete runs a 100-meter race. The idealized graph below shows how the athlete's velocity v changes with time t for a 100-meter sprint. By considering the area under the graph, calculate the maximum velocity of the athlete. Now, we know area under the graph represents the total distance traveled, right? So area must be equal to total distance traveled. And the total distance traveled is actually already given, right? It is 100-meter race, so the total distance must be 100 meters. Now we know the formula for area. Again, this is a shape that has one triangle in it and one square. So it will be the area of a triangle plus area of this square or rectangle. So area of the triangle will be 1/2 base, which is from here to here. It's 2 times height, which is u max. So I can write u max, and plus I have to add with it the area of this rectangle. So for rectangle, the base is from 2 to 11. You can see that it is 9, and times height is the same, u max. So this total area must be equal to 100 meters. Now you can just simplify, the 2's will cancel, u max plus 9 u max will give you 10 u max, and if you divide 10 on the other side, you will get u max as 100 divided by 10, which will give you 10 meters per second. So here the units for 100 are meters, and for the base, since we have time on the x-axis, this is in seconds, so meters per second. The second question is a bit more interesting and something new. Using the axis below, sketch a graph showing how the acceleration of this athlete changes with time during this race. Mark any significant points, significant values on the axis. Now you can stop the video and try to solve this by yourself. See, because this is the last question, so you should be able to get this right. Think about it, take your time. I'll explain it here. Okay, so we can see that for the first 2 seconds, acceleration is constant because the slope of velocity time graph is constant, right? It's constant slope, which tells us that here we have, in this region, we have constant acceleration. So for constant acceleration, you should not draw a graph that looks like this and think that this is constant acceleration. Constant acceleration means acceleration has a fixed value. If it has a fixed value, it should be a straight line for about 2 seconds. So this is 2, and until 2 seconds, the acceleration will not change. It will have a fixed value, a straight line, okay? And in the next 9 seconds, what is the slope of this line? It is exactly horizontal, right? It has no slope. So the slope must be 0. If the slope is 0, if m is 0, and we know that m gives us acceleration, that means acceleration must be 0. So after 2 seconds, for the next 9 seconds, for the next 9 seconds, the acceleration becomes 0, right? So now how can you represent a sudden change? Remember I said when something changes suddenly, you represent it by a dotted line, right? So you can draw a dotted line here like this, and then continue the rest of the graph from this point to this point. So this is how the graph will look like. Now, another thing, since if you look at the question, you have mentioned almost like you have given the answer on three different concepts. First, you have given your answer by understanding that constant slope means a straight line, right? So this is one point. The next is that you have labeled the time axis, so you will get another point for it. The next is that you have mentioned that the acceleration will drop to zero, which is represented by this line. You will get 1 point for this. But this question has 4 points, right? So you must at least give some other information, because they have mentioned it here, that mark any significant values on the x-axis. You have given some values for the x-axis, but we haven't mentioned anything on the y-axis, right? So can we figure out something for the y-axis? We can actually. We can write the maximum velocity divided by time. So Vmax divided by time will actually give us the acceleration, right, for the first 2 seconds. So Vmax, we calculated it from the first problem. It was 10 meters per second divided by the time. It is 2. So we can find the acceleration, which will be 5 meters per second squared. So we can label this point as 5 meters per second squared. I think this will get you full points for this question. Okay, this was the end of our first topic. And as you may have noticed, I was not going into the details because, like I said, this is kind of a revision, a crash course of revision for the upcoming exam. But if you want me to explain something in detail or some concept, you want me to make a video on some specific topic or specific chapter, let me know in the comments and I will try to upload a video. So happy learning and best of luck for your exams.